again. This is Alister McGrath at Oxford University, where I hold the Andreas Idrius Professorship of Science and Religion. And in the last presentation, we looked very briefly at what it means to explain something. We love explaining things. What does it actually mean? And it's important for us to be able to explain our world, to offer an account, no matter how incomplete, of the interconnection of events and forces in our world. And the key point here is that it's one thing to know that something has happened or that something exists, but I'm sure you can see that explanation matters. It's explaining why something has happened or why something exists. And that's why theories are so important in science and also in religion, because a theory offers us a framework, a mental picture, which helps us to understand why things happen or why they happen in a particular way. So how do we develop these theories? Well, let's begin by looking at a very important distinction between generating new theories and then testing these theories out. And some scholars make quite a helpful contrast between a logic of discovery, that's all about how we generate theories, and a logic of justification, that's how we test these theories. And a logic of discovery is about how we develop new hypotheses for consideration. For example, Newton's theory of universal gravitation or Darwin's theory of evolution through natural selection. And that obviously leads into a logic of justification, which is about testing these hypotheses against the evidence that's available. But in this presentation, I'm going to focus on the question of how scientific theories are developed. Now, as you may know, my first degree at Oxford was in chemistry, so let me begin by giving you a chemical example taken from the field of 19th century chemistry. Here's my question. How did the German chemist August Kekulé realize that the chemical benzene had a cyclical or a ring structure, as seen here? Happily, Kekulé told us how he did develop this idea, so let me tell you about this. Kekulé tells us that this idea of a ring structure came to him while he was drowsing in front of his fire at home. And he had a vision while he was dozing of a snake chasing its own tail. And this suggested to him that benzene had a ring, a cyclical structure. And having proposed this structure, Kekulé checked it out against experimental evidence and actually found it seemed to work remarkably well. So the way in which Kekulé came up with the idea that benzene had a cyclical structure is now seen as a classic example of the logic of discovery. And here's the point I want to emphasize. It's now widely accepted this logic of discovery is essentially imaginative or creative. It involves connections which we make, but other people have failed to make. And that's a really important point. We use our imaginations to generate connections and then say, let's check out whether they're really there. So that leads us to look at the logic of justification. Because logic of justification is what we use to check these things out. And what we find is the logic of justification is fundamentally rational and critical. It's about judging a new theory on the basis of the evidence in its support. And here's a really interesting point. The way in which a theory is developed actually is not of critical importance in determining whether it's true or not. What really matters is how well that theory can account for existing evidence and perhaps also predict new and unknown findings. But let's return to the logic of discovery, which is such an important part of scientific reasoning. Now, an early anticipation of this approach can be found in the 19th century American philosopher and scientist Charles Peirce. And for Peirce, scientific thinking can be described as a specific form of what he calls abductive inference. So let me explain to you what he means by this term abductive, because I think you'll find this interesting. Peirce is arguing that we begin by observing something that is surprising, something that doesn't really seem natural or obvious. And his point is that it may seem surprising because we're approaching it from the wrong perspective. If we approached it from a different perspective, using a different theoretical framework, the observation might actually be expected, not a surprise anymore. It's what you expect if this theoretical perspective is right. So you see, maybe the reason it's surprising is because we're using the wrong lens to look at it. So Peirce suggests that once an observation ceases to be surprising because we apply a certain lens or way of thinking about the context, that suggests the theory we have in mind might be right. And we can then check it out using the logic of justification. And a good example of this would be Albert Einstein's 1915 explanation of a puzzling observation relating to the planet Mercury that just couldn't be explained using the Newtonian mechanics. And the point is that the point at which Mercury's orbit was closest to the Sun actually shifted very slightly from one year to the next. And there was no obvious reason for it. But Einstein said, if you look at this through the lens of my theory of general relativity, this is exactly what you'd expect. And not only do you find it with Mercury, you find it with all the planets. You actually find it easier to observe with Mercury because it's closer to the Sun. And the key point is that Einstein gave us a different way of looking at things, and this advancing perihelion of Mercury, that's a technical term for this, would be expected in the light of this new way of looking at things. So we talked a bit about science. What about theology or religious belief? Now, I think there's a parallel here, but it's not, I have to say, an exact parallel. Writers like the philosophers Basil Mitchell and Richard Swinburne, or religious writers like C.S. Lewis and G.K. Chesterton, argue that Christianity provides us with what they call a big picture of things, which is able to make sense of the world we see around us and also what we experience within us. And Chesterton, for example, pointed out it was not any individual aspect of Christianity that was persuasive, but the overall big picture of reality that it offered. So here's what he says, I quote, "The theory, when it's adopted, works out everywhere. We put on the theory like a magic hat, and history becomes translucent like a house of glass." In other words, a theory illuminates. It enables us to see things. It makes things clearer. So how do we check out these possible explanations, these big pictures, whether they're scientific or religious? Very interesting question. So in the next presentation, we'll be looking at explanations and how we check them out. I think you'll find it very interesting. I look forward to speaking to you again very soon.